Electrical electronic engineering technology is a study of electronics. It's a hands-on program more so than just theoretical. So the student is actually working on theoretical problems in class, and then in the lab they get to do that hands-on.
Our EET major is actually two parts. We have an IET major, which is a 2-year program, and then those students go on for another 2 years to get their EET degree. It's a science and technology-based degree, so you're going to be doing a lot of math, you're going to be doing a lot of hands-on, you're going to be doing a lot of theoretical work, but on the other side of it is a lot of work with companies, internships. So at the end of it, the student's success is really based on not just the theory that you see in the classroom, but also the hands-on work that you do in the lab as well as, in industry.
This program offers a lot of different areas of communication, embedded processors, robotics, motion, industrial electronics, so there's a lot of areas here that can cover their interests.
I really like working with computers, or a computer engineer even, but I like working with computer hardware specifically. I collect old computer hardware and memorabilia, which of course things break, so sometimes you have to tear them apart and fix them.
My father has his own business, electrical goods, and from childhood I was just dealing with everything. So basically I just got the interest from my father.
Honestly, it can go in any direction. You can go into automotive, you can go into music, you can go into medical. Because electronics are everywhere. Everything you do has electronics and technology in it, and you're going to be working on that, developing it, and fixing it for companies.
We are very strong believers in hands-on training and taking theory into practice.
I really prefer lab work because in lab you will learn a lot.
There's a lot of hands-on in lab, and you're putting it together, you're testing with the equipment, and you're learning what you'd actually be doing for a job.
One thing that sets us apart, in terms of lab versus lecture, is that, you can learn things in lecture. You can learn the theory, you can learn the formulas, but can you really use them? So a lot of times I think of myself as kind of the bridge, the professor that has to teach the theory, but also go into lab and show how that theory actually works, in the real world.
We go to lecture to learn about all the circuits and the physics and the theory of what we're doing with it. And then we also have labs where we go and test the theories and stuff that we learn and actually apply them with physical components and programming, so we actually see what we're doing.
Our graduates tend to have a lot of ability when they get to the job to really hit the ground running, whereas a lot of other students from other places that get more theoretical background and not so much of the hands-on need to have a lot of training on the job. And that's something that we really pride ourselves at, because we find that employers come to us at the conclusion of our students' degrees asking for our graduates.
While I'd like to work in research and development for an electronics company, at the top of my list are NVIDIA and Oculus.
Personally, I would like to go into the automotive industry to design some of the new things with the AI and the new sensors on the cars and things like that.
You build things, you wire them, you see things work, you see lights light up, you see a program that executes and does what you want. To me, I think that's just so exciting when you build something that, it's like out of your imagination. And I think that's, a huge element the electronics has to offer.